Now let's explore an object-oriented way of doing um, our modeling and our data table. But before we do that, let's back up a little bit and talk about objects in Python. Um, so, in general, objects are the things, right? They're the nouns, the things that we make, that we use and change and share in our Python programs. And objects can contain both data and functions for using and changing the object. And if you've programmed in Excel VBA, you've done this. You've worked with properties and methods, right? Like the worksheet has a name property and it's got a copy method. Um, in Python, pretty much everything is an object. And we've already been using objects, things like array and lists. Those are objects. So let's explore kind of those a bit and just a little bit about kind of the built-in objects in Python. So I'm going to do the type of this order quantity range, and not surprising, it's an array object, and then data table 1 is a list, right? That was the thing that we made up here, data table 1, right? It's a list comprehension, so certainly that's gonna return a list. So and in fact, let's work with some of the methods in lists. I'm going to make a little list. I'm going to make a list from the order quantity range because it's a nice small list. So I can just use the list function to turn this array into a range. I'm sorry, into a list. And I'll print it out, and I'll print out the data type just to confirm that we indeed have a list, and we do. And you notice it's in brackets, it's comma separated, it's a list. If you've done any object-oriented programming, you've heard of the notion of a class. You can think of this is the classes are like templates from which you actually create individual object instances. And so like the list class, there's a built-in class called list that lets us create list objects. We can have as many as I want, and the list class is where all the methods and properties of lists are defined, and we can use those. And Python's got tons of different built-in classes and all kinds of predefined methods and properties. So let's do some really basic things, which I'm sure you've already done. Appending something to a list, right? We just use list.append, so list.method, and then we pass in the thing we want to append. Right? So append is a method. There's a reverse method for list, and we don't have to give it any arguments, but it is a method. That's why it has parentheses. All right, and that just flips it. And I could reverse the order again. I've gone back. And I pointed out, these things are methods, but I mean, methods are functions, and that's why they're followed by parentheses, and they may have input arguments. So now I'm going to do, instead of using reverse, I'm going to, instead of reversing the list, I'm going to sort the list. So I'll use the sort message. And there's actually a reverse argument for that, which actually means, sort it in descending order as opposed to ascending order. And there we go, we get our descending. So now what would happen if I called, for example, the reverse method and I forgot the parentheses? All right, so let's try that. Just leaving it off. Am I going to get an error? No, it just says, hey, yep, that thing is, that reverse is a built-in method, reverse, that's what it's called, of the list object. And this is the address of the specific list object, this OQ list guy. So it's just telling us that reverse is a function, right? It's a method. And functions are objects, right? They are objects as well as lists. And we can do things, since they're objects, we can pass functions to other functions. We can change some of their properties. You might be wondering, why I've never passed a function to another function in my life. Well, it turns out to be pretty handy, so we'll do that in a little bit. I'm sure you already know, for example, how to get items from a list, right? We can, the first item is 0 index. We just use the brackets to access the item at the 0th position, right? And there's 350. But really, that bracket notation is really just a convenient shorthand for calling one of the built-in methods of list objects. Well, how do you know what all the methods are of an object? Well, I mean, you certainly can go to the API, to help and Google and such things, but you can use the dir function. to see all the attributes of any object, all the properties, all the methods. So I'm gonna do that. Okay, so a couple things to notice. A bunch of these have both leading and trailing double underscores, and these things are known as dunder attributes. And these are just special names that are reserved by Python for very specific uses. And so you'll get used to kind of seeing these. Well, we'll use one of them right now. We're going to use the get item guy. And you'll see in Python, you'll see both single and double underscores. So I'm going to typo there. And if you want to read more about the meaning of underscores in general, but we'll end up hitting most of them kind of through our examples. Using brackets to access a list item is really just, we're really calling get item, this double underscore dunder method. So instead of using brackets, I'm going to use the get item and pass in the index, and I'm going to get the 350 back. Right? It's the exact same thing as before. Couple other things to notice, that all of these functions like reverse and sort, they worked in place. They operated directly on the list object that preceded the dot. Sometimes there'll be methods that that will create it. They won't work in place, and especially like in pandas, they'll create a new instance of the object. If you want to save it, you're going to have to assign the result back to a new variable or to your original object. This might remind you of, for example, in R, the dplyr package, right? It never modified data frames in place. All the dplyr functions like select, mutate, and filter, they always returned new data frame objects, and so you would just reassign the output either to a new variable or usually to the same data frame variable. All right, so let's do a little bit of further exploration on lists and copying lists and being careful about working with lists. All right, so I've heavily commented this, so I'm going to create a new list by taking our OQ list, and I'm just making a copy of it. All right, now I'm going to go ahead and I'll print it out, so it should look a lot. And now I'm going to say, hey, does the new list equal the old list? All right, well, it's a copy. It seems like they should have the same value. All right, are they the same data type? Certainly seems like it. Is the new variable actually the exact same object as the old variable? So new list is old list, or OQ list, is checking if they're literally the same object. That's different than checking if they have the same value, which is what double equals does. And actually, each object has an unique identifier, and its attribute, this ID function will return it. So I can call this ID function, and I'll get the actual ID numbers. All right. So let's see. So yep, there's our new list. Yep, it's got the same value as the old list, and yes, they have the same data type, but no, they are not the same object. And we can see they've got different ID numbers. Okay. So question, what do you think? If we reverse one of the two lists, would they still have the same value? In other words, does order matter with lists? So try that, for yourself to convince yourself that they will not have the same value. And that order matters with lists. There are other data structures in Python, such as the set, in which order does not matter. Okay, so all right, now that we've done this, really the reason I did this is I really want you to be careful when you're copying lists, and more generally being very careful when you're copying object variables. Okay. So let's remind ourselves, right? If I print out the list, there's OQ list. So now instead of using copy, I'm just going to set new OQ list equal to this one. Okay, so I'm just going to, and then I'll print it out. And now I'm going to reverse the original list. I'm not reversing the new list, but I'll print out the new list. And I'll print out their IDs. Okay, so notice I printed out the new list. I never touched the new list. I reversed the old list, and now I printed out the new list, and it's also reversed. And that's because they are literally the same object. So when you say something equals something in terms of objects, and they're literally just, it's like saying their memory address is the same. They're pointing to the same place in memory. So whenever we want to copy a list, we use its copy method. And for for other objects, we will actually use, there's a copy module in Python for doing what are known as shallow and deep copies of objects. Okay. All right. So just that's a little danger about working with objects. Let's look at the attributes now of a NumPy array and see how that compares to a list. Right? They're both data structures that allow us to store a bunch of values, and you can get at them via an index number. And so before you do this, think about, well, why might these data structures be different? And what kind of different properties might they have? And the first thing to notice is that arrays have way more properties than lists do. And even beyond the dunder object, it's got a lot of, in fact, you'll notice things like it's got a bunch of math functions, max, mean, min, right? So, and notice also there's a d-type property, right? The data type of the array, these integers or floats. So in fact, if I print out the type of this guy, he's a 32-bit integer. So it's just kind of a couple questions. Why don't we use why didn't I do this? Why didn't I put parens after that? And also, why don't lists have a d-type property? So pause, think for a second, and then review the answer. All right, well, hopefully you realize first, the d-type, we don't use parentheses because it's not a method, right? It's just an attribute, or it's a property of the object order quantity range. So we only have to put parentheses when we're calling methods. Let's see what would happen if we do it. It says, hey, NumPy d-type object is not callable. So anytime you see the something is not callable, it usually means you put parentheses on something that does not need parentheses. You're trying to call it like a function. Okay. Oops. And why don't list objects have a d-type property? Well, because we can store different types of data in the same list. We could have numbers and text, so it can't have a data type. All right, so finally, what about numbers? What about, things like integers and floating points? Really, are these actually objects too? So let's see. So I'll print out the unit cost. I'll print its data type, and I'll print out its attributes. And yep, it is an object. The class is called float. So there's literally a floating point object, and there's all its built-in properties and methods. And so if you want, you can try some things out. And also it has things like an add function, right? So for adding floats together. Hex, there's an is integer. Let's try it. Let's try unit cost dot is integer. So first of all, notice it comes back and says, hey, I'm a function. So that just means we need to call it. False, it's not an integer. Oh, that's nice. It's got a built-in method for figuring out if you're an integer. And then let's do unit cost dot hex. And there's the hexadecimal representation of that. Okay, so all right, so the point there is that everything in Python is an object, and we've been using objects all along here as we go. But when really we think about doing true object-oriented programming, we're really talking about creating our own classes. And Python supports object-oriented programming. It doesn't force you to create classes if you don't want to. Other languages like Java are much more built around object-oriented programming. You can actually blend procedural programming, object-oriented, and even something known as functional programming all into the same programs. But there's times when OOP, object-oriented, makes a lot of sense, and in those cases we'll use it. And also you're going to see that a lot of the data science packages are object-oriented. By the way, even if you know some Excel VBA, you may not know that you can actually create your own classes in VBA. You can actually do object-oriented programming in VBA. Most people, even who learn VBA programming, stick with the built-in Excel objects. Okay, in the next screencast, we will venture into writing our own classes, and we'll create an object-oriented version of the bookstore model.